Hello, welcome back to our discussion about simple hydraulic machine. As promised in the section 1 and 2, that I will show you how the manifold and directional valve working principle, and I will cover that things in this section 3 and 4. Okay, straight to design of simple machine of hydraulic system, as also shown in the previous video, season 1 and 2. So as you can see here, we have here what we call manifold. So I will explain in the short description. This manifold is kind of manipulations of room inside to accommodate the flow coming in and coming out, then transferred to this what we call directional valve. Maybe in your designs it's not directly connected to directional valve, maybe it connected first to what we call PRV, pressure relief valve, for you to make a system can be adjustable to the load you have. But that's a bit not simple anymore, but a bit above simple, yeah, but not advanced. Okay, concentrate our time here first. So this is the manifold. So the P here means these holes, it's deliver or receiving the pressurized fluid from the discharge of the pump. So actually this will be, there is a flexible valve here, a flexible hose here connected to pump discharge here, and then from the P inside it, then will be divided into two, A and B. So the port A and B, and return to the tank. So if I hide these things, you can see here port A, port B, and this is a port T, tank. So port tank, it means a return to the tank. Okay, and then from the tank connected to the suction of the pumps. So it's kind of a circulation. Okay, the volume of the tank actually around 3 times of the flow capacity of the pumps, and plus with all the fluid inside this hydraulic system when it's fully running. So to ensure that fluid will be not shortage, so minimum 3 times will be not shortage. For example, you have a flow capacity let's say 23 liter per minute, as previously said. So if you want to maintain the capacity, let's say in 3 minutes, no shortage, yeah, so you have at least have 3 times plus all the volume inside this. So let's say it's 70 liter or 50 liters, that the basic one. Someone design maybe only 2 times or 1/2 times, but to avoid the fluid very hot, usually 3 times. But it's also depend on your working machine, yeah. Maybe the machine is only start and stop in short time, not continuous. That depends of your machine application. So in this case, back to this in this application. So we have a port A, port B, and tank. So we want to discuss this manifold first. So I would like to open the drawing. I designed this by myself, yeah, but this is very simple. You can design also by yourself. So if I open, the material is a slab steel, yeah. You can buy the slab steel from the market, and then they machining it, yeah. After they make a square based on your size. So there is a hole here. They drill the hole by, of course, by using lathe machine, yeah. And also there are hole here. So how actually the hole inside, yeah. So for the beginners of the hydraulic engineer, they maybe very confusing what is this hole mean, yeah. So I believe section view is more more clear to show what actually inside it. Okay, make a section view like this. This is the beautiful of the SolidWorks. You can make a section view. Okay, I confirm this. So this is a tank. This is the port A, port B, and this is the port P. Okay, so it means when the hose from pumps the fluid flowing to here, okay, there is no chance for for the fluid to go anywhere to here, to here, to here, because it already actually blocked. Yeah, actually blocked. Yeah. How they make this hole? Of course, they drill using lathe machine. Okay, it's actually blocked, and this is why connectivity here, because I would like to connect this with what we call as pressure gauge to read how much the pressure generated by the pumps, yeah, by the hydraulic pumps. And then why they make a hole here? Of course, when it block, it will go to other place from here, yeah. I will explain later on, because at the top there is also hole connected to directional valves, yeah. So why they put here? Of course, to ensure that there is a connection to 4 holes here, yeah. So they drill it, and then later on they blind it, yeah. There is a blind as kind of 3D blind, yeah. So let's, for example, I put like this, because above there is a hole, there is a hole that connected to others. So as I already put the section view, there is no chance for the fluid flowing to other place. So the only chance the fluid flowing is to the top, because we drill the hole at the top. Okay, this one, the hole. So if I make a section view, yeah, like this. Let's say, for example, this one. Okay, so we check this one, what it is. So there's a P port flowing there, and then the fluid will flowing up. There is no chance of this port P flowing to the left or to the right, so only chance to the up, to the directional valve port that I will explain later on. Okay, this is for the port P. How about other port? Yeah, how about other port? Let's go to this. Okay, this other port, as you know, we have a port A and B here, yeah, also flowing up. Okay, also flowing up. There is no chance between port B and A mixed together here in the manifold. It will flowing up. Okay, then if I make another section, say for example like this. Okay, this is the tank port. Yeah, tank port also flowing from this direction to this direction. There is no chance mix uh, with this all the port inside the manifold. So the port A, B, pressure and tank, there is no chance from them to mix inside this. Yeah, so this is a kind manifold is a place for that a room for the flowing. So this flowing will go to the directional valve above, and the directional valve will manipulate the direction of the flow. Okay, so far I think it's quite clear. Yeah, quite clear. And this size you can see on the catalog, the whole diameter you can see on the catalogs and etc. I use this thread NPT, yeah, or hydraulic, you can see in the catalog. So that's it, the manifold. And then the manifold usually the bulk material, and then they drill it by machinery. Then they don't do casting for that. They drill it. Yeah. So this is a very simple one. To make it a bit clear, if I hide some of the sketch, so to make it transparent. Okay, this is looks like, yeah. This is a look likes if I make this transparent. So this is the pump port, the pump port from here, and then flowing it to up, and tank port receiving only alone as well, and B port and A port for up or down, yeah, flowing to this. Yeah, so this is a very clear view inside how it looks like inside. So it can be done by machining, no need casting for this. And as I explained before, why they make a hole here, because they have to drill to this direction to have this hole connected to here, and then after that they blind this, because there is no chance to drill from here and suddenly the tools able to drill to this direction. There is no technology like that, I think, till right now. Yeah. And then this 4 hole is what we call, this is the hole for P pumps or pressure section, for A and B, and for tank. And the dimension of this, the distance and diameter, is ISO standard for all the models, all the manufacturer. You can for this type of kind of a hole arrangements, this for plus hole arrangements, all the same. All the same. The distance is follow the standard. There is also another way or arrangement of the holes for the other type of the valve. You can check the catalog. So for the example is this 4 holes following the ISO standard. So I think that's the clear view. So if I make this a bit transparent, okay, you can see the room inside. I think it's more very clear. So I repeat again, from pumps will be flowing up here, tank will receive from here back to the tank, A will receive from here to here, B will receive from here to here. Okay, I think that's very clear for you to have this manifold view. Yeah. So again, a guy that asking in my channel how actually manifold looks like. So I think this explained clearly. I use this CAD. I designed this by myself. But maybe if you don't want to manufacture it by yourself, Actually, the company like a Yukon or hydraulic company, they also provide the manifold, from the simple manifold until the complex manifold. You just check their catalog. So I believe they will make it cheaper, because they make it in the big lots to all their customers. But the weakness is you have to design things to fit that dimension. You cannot modify the length and the height, etc. So there is a pro and con for that. But to save cost, you can consider their manifold. Okay, so back to our presentation here. So after you understand the manifold inside there, okay, that manifold, yeah, actually the hole will be connected to this directional valve. So if I open this sub-assembly to be more concentrated for that, that's the situation inside. The holes here match with the hole of the directional valve and ISO standard, yeah. And from this we will start to have a deep look what inside this directional valve. Okay, I personally I open the directional valves, this type of directional valve, closed center directional valve. I open it, I redraw to ensure you understand how it's working principle. It's very simple. It's very old technology for the AG for maybe 1,000 years ago, but that concept is translated into directional valve by using electricity and etc. In the past, if you go to university times, you check in the library, this kind of flow manipulation is not new. It's already there many centuries. It's only the applications adopt to our technology after we have industrialization. We invented electricity and etc. Okay, short story, we go directly to directional valve that I already actually redraw it for you. Yeah, I click this and then I open the sub assembly. Okay, let's say I make this not transparent. So this is how it looks like of the directional valve. The next video I open the directional valve physically, so you can compare CAD and the physical real physical of the directional valves. Yeah. The good things of the CAD today is easy for you to do many things as you want it. So also I encourage young mechanical engineer, you must be able to use 3D CAD. So I just explode it like this, exploded view, so you can easily see what actually inside. So I have here the main manifold of directional valve, and then there is inside, we call it a spool. So let's say I put this transparent. This is the spool. This is actually the guy or the things that responsible to manipulate the flow, because it can move to the right and to the left by energizing this coil. So let's discuss about the parts first. Yeah. So this is a lock, nothing to do with this lock, and then this is the coil. Actually this is AC coil, or you can also maybe you want to have a DC coil, up to you. And then this is main shaft, because inside it there is a kind of free moving metals that when this is energized, that metal will be moved and hit this one, this small plunger, and then small plungers will hit to this directional valve, and directional valve will be can be moved to other direction, for example to it moves to other direction, and in also in opposite directions, if you energize this, it's also hit this one, and this spool will move to other direction. When it moves to other direction, that's when the flow is actually manipulated from P to A, from P to A, and back to tank. Okay, inside there is electric connection cables. This have three wires, one for ground, neutral, and live. And this is a kind of a seal rubber to avoid the short circuit to the body. And this is for the nameplate. Let's say I unexplode collapse to explode, and then if I animate, like this. Very interesting. This cat. Not now. I already use 3D CAD, I think from 16 years, but year by year they have improvements. They innovate year by years. Okay. Okay, now you already seen the part of this directional valve inside the coil. So it's very simple. Now the key point is we want to discuss what we call the main principle or working principle of manifold of this directional valve, the manipulation of the flow. Okay, I think let's hide this, and then hide this as well. Alright, already hide. Okay, we go to the bottom. Poof. Okay, there is there are 4 holes that's connected to the manifold. Okay, these are P. Yeah, this is A, B, and this is 10. Okay, how it manipulates? Let's check. Okay, how it manipulates? Let's check. And then how to check, we make a section view. Okay, this is the correct one, I think. Alright, this is the section view. So this is a P port from the pump port to pump to the manifold, and then connected to the to this one port. So this P port connected to this area and this area. Okay, so when the pump operates and these two sections connected directly, and the pressurized fluid connected to it directly, it means the spool at the center, this spool, you have a spool here, as I mentioned before, it balance, left and right, so there is no possibility this spool move to the left or to the right, because when the pressure pressurized pump, let's say 10 bars to the left, 10 bars to the right, and there is no spool movements, it will be keep at the center, because the force at the from the left and the right is the equal, and the sum of the force is 0. There will be no movement at all. Maybe there is a small movement but not affect the system. Yeah. So the P port connected to this area. Let's check in other way. Okay, to make it a bit simple. Okay. All right. So now you understand that I think how it manipulates from either positions. When the pump operates, move like this, there is no spool movements. We call it closed center. There is no flow to the port A and B. It moves there and keep there forever as long as the pump is on or whatever off. The balance of the force will be there. Okay. So how if I let's say the left coil on, what it will affect? Okay, we discuss now. So I move like this. Okay. Alright, so to have a feeling, I move like this for first, so you can see how it looks like inside. Okay. Alright, this section. So this is a P port, pump port, as I explained before. When there is no energization of the coil from left to left or right, and this spool stay there, and the fluid pressure and the force become balanced left and right, spool be there, pump still on, what we call a closed center. Okay, when pump on, closed center means the pump is not back to the tank, is always like that. Why we sometimes we use that closed center or open center, that will be other discussion. But what I would like to explain here for you, when pumps operate, fluid from the manifold flowing to here, and the direction to the here, and then to here, both directions balance the force. But the question is now, how if I want to direct the flow to the E port, for example, B port, for example. Okay, now we discuss that. Sorry. So for example, I want, this is this E port, yeah, E port or B port. Let's check. Let's check. Okay, this is B port. Yeah, B ports here, moving to here, so it's down. Yeah, oil move to here, press here, and then lifting table is going down. Okay, so it means the fluid from here, from pump port here, okay, must be flowing to this area. How it happens? Spool activated at the right sections, and then coil activated at the right section, and then spool moving to here. Bam. Okay, so the fluid from here move to here, or flowing to here directly, finally, yeah, reaching this port, what we call B port, and then B port flowing to the manifold, and then as you can see in the manifold, let's check the manifold. Here, that's what we call a B port here. Let's open it to make it more clear. Okay, this one. So that's a B port here. So this is the B port here. So the fluid flowing to here, and then finally out from here. So we can check again from this directional valve. When the spool moving here, yeah, the fluid from pumps here move to here because there is a already opening here, okay, and move to here or flowing to here, and then from that hole, if we check the manifold here, yeah, moving to here, moving to here, moving to here, moving here, out here. And if you check in on the main assembly, out here is okay, moving here, and then pump lifting table will be moving down, yeah. And this is what we call is needles flow valve. So if you want the moving down is a bit slowly, you just choke it, yeah. If you want to make it faster, just a bit opening, yeah. Okay, that's when you want to open this port. So it will be open as long as what you need, but it will shut down based on your system. Maybe when you hit proximity, the electricity to the coil right will be shut down, and then it will move back again to the closed center, because we have a spring here, as I shown in the exploded view. That's will make it move to its original position. So okay, that's already flowing to that direction. Okay, how about this port? Okay, this port is a B port, this is a port, yeah. Why we want to talk about that? Because the only possible things that can be moved down, as long as the oil at this port flowing to this A port and also flowing to others area. So this other areas is a tank area, return to the tank. If not, it's not possible to move it down, because you know a hydraulic mechanism using fluid, and the fluid water, of course, fluid, but this fluid in the liquid phase is incompressible. It's different with the air, other fluid, still compressible. If you close the door, there is also still possibility that it's still moving down, but liquid phase almost impossible. It's very very small, 0.1 millimeter. So we have to ensure that the oil from that direction will have to move back to the tank. So to have a chance that this area occupy with incoming pressurized oil. So how it back to the tank? Okay, let's see. So here is a port, as we discussed, this is a port A, this is a port B. So the liquid now flowing to here. Okay, now this open. Okay, you can see this is open, right? This is closed, but here already gap. This is closed means the liquid from this B port, yeah, it's not possible to move to here. It's only possible to this direction, and then this direction will be flowing to the hydraulic cylinder. But here, see, there is opening. It means the oil from this port that go to this A port now has a chance moving to this zone, and this zone is tank port. Okay, How do you know that's a tank port? Let's check. Yeah. So this is the situation. Yeah. There. Okay. This the situation there, and then let's make another section view. See this. So this is more clear. Yeah? The liquid from the return from to the airport, there is a gap here opening, there is no opening here, it's closed, moving here, and then it goes to this holes, and this hole is a tank port, T port. So now I think it's very clear. Yeah, I think now it's very clear. So let's examine something that maybe this make it transparent. How inside looks like this. Okay. Yeah. Okay, make another section view. Okay. Oh. Okay. All right. Now the opposite direction. If I want lift up, it's very easy because you already understand when it's down, when it's up, also easy. Of course, after it's back to the center like this. If you want to go up, this will move like this. Okay. This is of course as a B port. This is a port. Yeah. So now the pressurized oil from pumps moving to this direction with this opening. Yeah. Moving to this sorry to this directions. Hold on please. Okay, this is a beautiful of the cat, so you can. Alright. Okay, first we have to make it when it neutral position. Okay, we already discussed when it moving to here. Okay, now we want to discuss opposite direction when it moving to here. Oh, like this for example. Okay, and then move like this. Of course, now the pressurized part is now moving not to the B port anymore, now to the E port. This is a E port, so the pressurized oil moving to here, showing this gap, and then go to here. And if you check the assembly, okay, now fluid flowing from A connected to here, and then lifting cable raised up, and then the now B port receiving a returning oil to here. So it's very easy now because we already explained that. So this E port, yeah, moving to here, the oil go to the B port, and the oil from go to the A port, and oil from the B port return to here. Okay, return to here, and then go to this next chamber, and the next chamber, as you know, is a tank. Okay, that's it, because there is a gap here. See, there is a chance to flowing here. Okay, here there is no chance to mix. There is no here also. Here the pumps are sending to the pressurized heat fluid to the E port. There's a chance to mix here, but there is no chance to mix here. The only chance this room get a mixing is from here, returning from B port. Yeah. So that's the situation. So if you want to go center, it's idle position. You go to the right. Okay, it will be the hydraulic will be down, and then you go to the center, it's stop, and go to the left, hydraulic piston will press up. As simple as that. Yeah, as simple as that. But if you think it looks like the situation is different with the manifold. Yeah. The manifold, as I explained before, you can make a square from slab steel and then you drill here and there. But here, if we are very familiar with the machining and has experience with the machining, lugs, drilling, and etc., or the university times, it's not possible to make a room like this by machining, because we have undercut. So how tools going in this room and cutting this, and then when it move back hit this wall? Impossible. And the room itself, if you go to a bit back, there is room inside here. How to make this room or this chamber? Till now there is no technology drilling, go up and suddenly to the left and then find another way. There is no till now. Maybe Elon Musk maybe invented that concept. Yeah, maybe with nanotechnology, and I don't know, but there is no. But how they make it? There is no possible way. The only way is they have to do it with casting. So they have a course. Yeah, they have a course. Yeah, but I believe they do it with the wax casting. The core is from the wax, and then when you pour it with the metal, the wax will be melted. Yeah, after they heat it, they melt it, and then it creates rooms, and then the next step is to machine to drill the hole to make it bigger and etc. But for sure these holes, these holes, undercut hole we call it never been machined. It cast, it had course. Yeah, maybe they use a sand casting, etc. And not possible to use a die casting. Yeah, because female and males for die casting must be exactly, can be opened directly for horizontal and vertical, or horizontal, vertical, but this is not possible. In my next video I also explain that, so to have a feeling about the real products, that possible things they only do it that by casting, wax casting. You can check in the Google how it wax casting done. And I explained also when I was in China, I think 12 years ago, not 11 years ago, I visited one of supplier. I witnessed wax casting there. Everyone can do, because you have your simples, and the people there do the wax castings easiest way. Prepare the wax, prepare the cores. Yeah, the course is really terrible shape, yeah, not symmetric. It's not a problem for the wax casting, because one of the good things about the wax casting, the course no need symmetry, because after you make the profile and etc., and you put it in, let's say to the mold, and you pour the liquid metals, and after sometimes liquid metal already become solid, the wax it can easily destroy it. Yeah, and then the wax surface is why they call it wax, because they make it from wax. Yeah, the surface, yeah, will not burned by the liquid metal, but is not hard to destroy. So after they pour the liquid metal, and then the liquid metal becomes solid, and the next step is how to destroy the wax. Very easy. I witnessed by myself when I was in China, and I admire China do that in very easy way, and then people there's just a home industry can do that. Yeah. So that's the key point that I already explained to you. I believe my English can be understandable, and then sorry, now you understand how the hydraulic machine work, yeah, and how the flow manipulated inside there. Don't miss my previous video to have a good relation to here, yeah. Okay, so I let's say open others, yeah, so to make it a bit clear, to make it let's if I change this, okay, say if I change the transparency of this is, oops, what happened? If I change the transparency, this okay, it will be more clear, yeah. So it will be more clear. As you can see, this is the room, and then there is a room here, a pump port, yeah, that not possible used by machining, yeah, not possible, as I explained to you, by wax casting. Okay, see, so it's kind of it manipulate the direction, yeah? So the pumps from here flow into this room and this room, two rooms. If there is no energized energy to the spool by through coil, the force balance left and right, and there is no flow. That for the case of open center. For closed center, for the open center, of course, it cannot be like this anymore. But only I explain for the closed center. Open centers, I think you can think about it already. So it's kind of manipulation there. So to summarize, what's the key points? The key point is manipulating of flow direction by, of course, by this spool, and then in the spool it has a housing, what we call a manifold house for the directional valve, and how it energizes using coil, yeah, and what kind of coil. Of course, you have a 24 DC or 220, depend of your request. And then this kind of manipulation is not a new technology or new concept. 1,000 years ago, if you read the book of history times, already apply in the pyramid and etc., gate opening and etc., and also applied here because we invented, our scientists invented electricity, so it's more usable and wide use, yeah. Okay, if you want to have this material, you just post the email. I can give you this free for you to learn, yeah. And don't forget to see previous video to have a relation, yeah. And then next video after this, yeah, is how I open this physically open the valve here. So thank you. I hope you now understand better, for you that new to this hydraulic, and keep learning, yeah, for the new things, to have a very good experience in engineering. Thank you very much. Have a nice day. See you next video. Bye bye. Hello, welcome. And on your screen you can see the physical view of the directional valve for hydraulics. Let me zoom the symbol of this directional valve Yeah, this is the symbol activation of the coil. At the symbol left and right, everything closed. It means there is no fluid out of this directional valve flowing to any other direction. So they call a closed center. Okay, so we concentrate our video on what is inside this directional valve, so to make it us more understand of this very important part of any fluid mechanism system. Okay, first let me open what we call as electrical port. For this case, this one is AC 220 volt coil for the right side, and this the left side coil is AC 220 volt as well, AC. And this inside the coil there is a kind of conductors like a wires. So when the wires here in the on positions, it can generate what we call magnetic fields inside it, and these magnetic fields will pull out the rod. We can see inside later on how it looks like. So let me open it. So I open here for the port for electric. See here, there is three port. Yeah, one positive, negative, and neutral. Sorry, one positive, neutral, and then ground to protect for the short circuit. And at left side also as well, same. Yeah, and this is the mechanism. Yeah, it's kind of a plug system. Yeah, so usually you put your wire here, take it into, actually you can open this, you connect here, and you can connect cables into this port. Yeah, and then you close again. Yeah, that's it. Next, we want to take out the coil, so you have to turn this like this. So this is when the coil already take out. Yeah, and now we have to take this as well, because inside there is a shaft mechanism. Take out. Now it's easily turned because I already opened it before, just to show it. To takes times to open it. Yeah, because it's very hard to lock. Yeah, so that's what you can see. Oh, so there's a spring here, it's kind of ring. So inside there is a spring mechanism. If you open, and then you also can push this, so when the electric magnetic on create magnetic fields, and this mechanism will be sucked to this direction, move to that direction, and then when it off, back to this direction, because there is a spring here. Okay, same at left side. Yeah, let me open. Same, it's also spring and small plunger here. Okay, now this is the main one, to manipulate the direction of the fluid flow inside. So this is a huge rigid one. Okay, there is no any interconnection, it's a rigid. Okay, it's rigid. So if I push from these directions, there is a what we call inside it's a spool, yeah, spool that helping the system here to manipulate the flow direction of the fluid when it moves to the right, when it moves to the left. Okay, let me dismantle this spool and show you what the spool looks like. It's very tight tolerance, yeah, because to avoid any leaks between one room to another room, because inside this there is a room, manipulated room. Okay, this is how it basic looks like. Oops. So this is how it looks like, small one, and then the material is, I think, is very quite hard, and this surface will be hardened because many friction here, yeah, during open and close, yeah. Okay, so how the holes look like? Now you can see, yeah, holes from this direction to other direction. Okay, at the bottom side, really interesting, also holes, yeah. So to make it faster, if you see the user manual of this directional valve, this is P port, this is a tank port, T port, this is a port, this is a B port. Can see the symbol again in very close looks, yeah. Okay, so because this square directional valves rigid, there is no any connection between top and down. How actually they make it, yeah. So back to my previous video presentation, I designed, I redraw and design how it looks like inside it. It more easier for you to understand, and then how they make it. So for of course, because there is undercut, yeah, undercut that not possible by machine, so it means they already do that in the casting, yeah. So wax casting, so they make a core. After some time they destroy these cores by others methods, and that create rooms. And then of course they also have to make a pre-drill room, so the machining will be drilled here, but undercut uh, room made by actually casting, wax casting. When I was in China around 12 years ago, I visit one of our supplier there. Wax casting is very easy one, it's very common there, and uh, I saw the process, so I can understand, I can feel the process at the time, and so I can say to you, mostly they make this first by wax casting, then after that you destroy the cores, yeah, and then room created inside. So if we close zoom, yeah, if a close zoom, this is what inside, there is a room there, yeah, there is a room inside there. Unfortunately, to prove it better, I can cut this, yeah, but this directional valve still in good operating way, yeah, no damage yet. So no, I mean there is a scratch, but there is no actually big damage, so it's kind of wasting if I cut this. But previous video already showed to you how it looks like in cat, yeah, so you can understand. But the purpose of this video to show the real part is to have a feeling, actually to have a feeling what inside, so we can understand better. So this what they call it is call as a spool, yeah, it actually moving to this direction and to this direction by actuating of this coil, yeah, the spool move there, and then when there is no more electric power and there is no magnetic field created, it will be move back by helping of this spring. So you can imagine install like this. Imagine this a cut section. So you have this, yeah, and then you have this, yeah, and this casing to this casing, yeah. So you can imagine that, or I can replace like this, yeah. So it will move, yeah, if this energized by magnetic, by electric, and create magnetic field. So it can move very gently, move, let's say 2 mm, 3 mm, 1 mm, 2 mm. So it can manipulate the direction of the flow. You can brand made in Taiwan. So that's all about what inside. So very easy to understand right now. And then this spool, if I zoom, maybe you can notice some scratch already here, some scratch here, yeah, you can notice. And then if your fluid mechanism has no power to leave, the main reason may be because of there is scratch here. One of the reason, other reason you have to investigate, but at least you can understand the mechanism, and then I believe you can solve the problem easier.